Hello everyone, welcome to Engineering Explained channel. In this session, I am going to discuss the pump performance comparison factors. Here as we know that in the hydraulic system, one of the important component is the hydraulic pump, which is the power source for the hydraulic system. And there are different types of pumps already have discussed. Their working, classification, all these things, their performance I have discussed. And out of these pumps, which pump is to be suitable for the particular system and which is better as per its performance, as per their price, all these things I am going to discuss in this session. Here I am going to take one chart. That chart gives the comparison of various performance factors for hydraulic pumps. In general, gear pumps are least expensive. Gear pumps are least expensive but also provide the lowest performance, lowest level of performance. In addition, gear pump efficiency is rapidly reduced by wear after using this particular time period, which contributes to high maintenance cost. The volumetric efficiency of gear pumps is greatly affected by the following leakage losses, which can rapidly accelerate due to wear. Where is the cause for the leakage losses, and those leakage losses will reduce the volumetric efficiency. These leakage losses are due to leakage around the outer periphery of the gears, leakage across the faces of the gears, leakage at points where the gear teeth make contact. These are the cause for the volumetric efficiency loss. Gear pumps are simple in design, but they are simple in design, compact size in size. Therefore, they are most common type. They are most common type pump used in fluid power systems. Even though their efficiency is low, the maintenance is required, but due to the compact size and simple design, they are most common type of the pumps which are used in the fluid power systems. The greatest number of applications of gear pumps are in mobile equipments. The mobile equipments where the we can transfer the system for the different applications, and machine tools where we are going to use these gear pumps. Okay, now we'll take that is comparison. The comparison parameters are first one, pressure rating pounds per square inch, speed rating rotations revolutions per minute rpm, then overall efficiency in terms of percentage, hp per lb, that is a horsepower per unit ra- weight ratio. That one lb is a weight, hp is a horsepower. Okay, horsepower to the weight ratio. Flow capacity grams per minute, cost in dollars per hp. For 1 hp capacity pump, what is the cost of the pump is there in terms of the dollars? First we'll take the external gear pump. Its pressure rating varies from the 2000 to 3000 psi, speed rating 1200 to 2500, overall efficiency is 80 to 90%, hp per lb is 2, and flow capacity is 1 to 150 grams per minute, and dollar cost 4 to $8 per hp. The next internal gear pump, the pressure rating is less, that is 500 to 2000, and speed rating will be almost same of the external gear pump. There is a 1200 to 2500. Its efficiency is less, that is 70 to 85%. And the hp to lb ratio 2, again it's same, and its flow capacity rate will be somewhat higher, 1 to 200 gpm, and the cost will be same for the internal gear pump also. The next vane pump, its pressure rating will be somewhat from lower range to the middle range compared to the external gear pump. There is a 1000 to 2000 psi, and speed rating is around 1200 to 1800, somewhat lesser. The efficiency is almost near to the that external gear pump, and somewhat higher, 80 to 95%. And HP per LB ratio is also 2, and flow capacity is very less here. For the this vane pump, flow capacity is very less, 1 to 80 GPM, and its cost is also higher, that is 6 to $30 per HP. And axial piston pump, for that the pressure rating is higher, 2000 to 12,000 psi, and speed rating is also range is higher, 1200 to 3000 rpm, and overall efficiency is 90 to 98 percentage. Overall efficiency, we can see that it was very high efficiency axial piston pump is having. And HP per LB means for 1 HP of the its power, the LB weight will be more. The weight will be higher here. And flow rate is 1 to 200, and its cost is also higher, 6 to $50 per HP. 6 to $50 per HP. And radial piston pump, its again pressure rating is increased 3000 to 12,000 psi, and speed rating is almost similar to that internal vane pump, that is a 1200 to 1800, and efficiency is higher, somewhat less compared to the axial piston pump, 85 to 95 percentage, and HP per LB is less than that of the axial piston pump, and its pressure rating, flow capacity is same that of the axial piston pump. Both the piston pumps are having the same flow rating, and somewhat less cost will be there. There is a 5 to $35 per HP. Like this, the comparison we can do. Then, what the preference we have to take? Now, I am going to discuss next. Vane pump efficiencies and cost fall between those of gear and piston pumps. Okay, vane pump is between the piston and the gear pumps. Vane pumps have good efficiencies and last for reasonably long time. However, continued satisfactory performance necessitates clean oil. The clean oil is required with good lubricity, that is also required for this. Excessive shaft speeds can cause the operating problems. Leakage losses in vane pumps occur across the faces of the rotor between the branch wear plates and pressure ring. The leakage is also taking place in this vane pump also. Then moving to the piston pumps. Piston pumps are the most expensive and provide highest level of overall performance. You can see that is most expensive and provide the highest level of overall performance in all parameters. They can driven at a high speeds up to 5000 rpm to provide a high horsepower to weight ratio. The higher horsepower to weight ratio we are going to get for the given weight, the higher horsepower it will be there. They produce essentially non-pulsating flow. Non-pulsating flow they will produce and can operate at the highest pressure levels. The pressure level is also highest as we seen in the chart. Due to very close fitting pistons, they have the highest efficiencies. Because of the close fitting of the pistons, they have the highest efficiencies. Since no side loads occurs to the pistons, the pump life expectancy is at least several years. The life is also higher of the several years. However, because of their complex design, piston pumps cannot normally be repaired in the field. If the maintenance comes that one, that cannot be repaired in the field because of the complex design. Okay, that is the difficulty associated with this piston pumps, and cost is also somewhat higher. And where the cost is the main factor, we cannot use the piston pumps. Okay, if the performance is the highest requirement, then we are going to use the piston pumps, and in between the range we are going to use the vane pumps. And if the cost is the main factor for the using of the pump and size and weight, we have to use the gear pump. This comparison we can see, and from that we'll get the idea which pump is to be prepared for the which type of the piston, which type of the hydraulic system. Thanks for watching the Engineering Explained channel. Kindly subscribe, share, and comment